What if I told you there's a loophole, a glitch in the very laws of physics, a bizarre connection that lets two particles, even if they're on opposite sides of the universe, communicate instantly? Now, this isn't some wild theory. It's a proven fact about our reality. And it's so strange, it literally spooked Albert Einstein. Okay, let's dive in.
Yeah, you heard that right. Einstein himself famously called this spooky action at a distance. He was totally convinced it was a flaw, that our understanding of quantum mechanics was, well, missing a chapter. For him, the one rule to rule them all was that nothing, and I mean nothing, can travel faster than light. And this instantaneous connection, it seemed to shatter that rule completely.
So that's the core puzzle for us today. How is this even possible? How can you measure a particle right here on Earth and instantly know something about its partner, even if that partner is in another galaxy? You're going to want to stick around because the answer leads to technology that sounds like it's been pulled straight out of a science fiction movie.
To really get our heads around this, we need to rewind the clock back to one of the greatest scientific showdowns in history. A real clash of titans fighting over the very nature of reality itself. It all kicked off with a thought experiment in 1935 from Einstein and a couple of his colleagues. Now, they weren't trying to discover something new. Nope, they were trying to poke a hole in the weirdness of quantum theory. They argued that this spooky connection must mean there was some hidden information, like secret instructions the particles were carrying from the very start that we just couldn't see yet. And this is where the two heavyweight champions of physics went to their corners. In one corner, you have Einstein's local realism. This is just common sense, right? A ball has a color even when you're not looking at it, and things can't just magically influence each other across the universe. But in the other corner, you've got Niels Bohr and the quantum view. They said a particle's properties, like its spin, literally don't exist until you measure them. And those two linked particles? They aren't really two separate things. They're one single system, no matter how far apart they get.
So this bizarre, spooky, universe-spanning connection that Bohr was talking about, it has a name. It is the absolute heart of this whole mystery, and it's called quantum entanglement.
The most important thing to get is this. Entangled particles are created as a pair. From that first moment, they are fundamentally connected. You measure one, and you instantly influence the state of the other. It doesn't matter if they're in the same room or on opposite ends of the cosmos. Their fates are one and the same.
Look, I know it sounds weird, so let's try a simple analogy. Imagine we have a pair of magic coins. They're linked, so they are guaranteed to always land on opposite faces. Now, I give one to you, and I send the other one on a rocket to the moon. You flip your coin, and it lands on heads. Bam! In that exact split second, you know with 100% certainty that the coin on the moon is tails. No signal was sent, the information was just there. That, in a nutshell, is the essence of entanglement.
For decades, this was just a weird philosophical debate for physicists. But then scientists realized this spooky property wasn't a bug, it was a feature. In fact, it was a feature you could use to build a whole new kind of technology.
It turns out entanglement is a resource, a way to encode and send information that just completely bends the classical rules. It's a quantum superpower that lets us do things that really should be impossible.
And here's one of the first amazing applications, quantum dense coding. You've got Alice and Bob, and they each get one particle from an entangled pair. Now, Bob wants to send a message. Classically, sending his particle would carry one bit of information. But with entanglement, Bob can do one of 4 little operations on his particle before sending it to Alice.
So when Alice receives Bob's particle, she measures it together with her own. And that joint measurement instantly tells her exactly which of the 4 things Bob did. 4 possibilities. In computer talk, that's 2 bits of information. He sent a single particle, but he successfully transmitted double the data.
Think about that for a second. It's like sending a secret 2-word message using only a single letter. It's a complete information hack, powered by that spooky connection.
But doubling your data capacity, that's just the warm-up act. The truly mind-blowing application takes us from sending extra information to sending the information of an object itself. Yes, we are talking about quantum teleportation.
Now, before your mind goes to beam me of Scotty, let's be perfectly clear. We're not talking about Star Trek. This is a real, proven, and experimentally demonstrated process, all based on the fundamental laws of our universe. And this right here, this is the blueprint. It might look complicated, but the concept is just stunningly elegant. Let's say Alice has a particle, and she wants to teleport its exact quantum state over to Bob. The problem is, she can't just measure it, because the very act of measuring would destroy the information she's trying to send. So she has to get clever.
Here's how it's done, step by step. First, Alice and Bob share an entangled pair, just like before. Then, Alice takes the particle she wants to teleport and performs a special measurement on it and her half of the entangled pair, together. This measurement completely scrambles the original particle. Its identity's gone. But it gives her a result, 2 classical bits of information, which she can just send to Bob in a regular old email.
And here's the magic. Bob gets that email. The 2 bits tell him exactly which of 4 operations to perform on his half of the entangled pair. The moment he does it, his particle transforms into an exact, perfect replica of Alice's original particle. The information that defined the original has been transmitted across space and used to rebuild it in a new location.
So this is all mind-bendingly cool, but why does it actually matter? Well, this spooky little curiosity that bothered Einstein so much has become the foundation for a technological revolution that's already starting.
We're talking about completely unhackable communication networks. Any attempt to eavesdrop would instantly be detected. It's the engine that's going to power quantum computers, which can solve problems that are impossible for today's best machines. It's letting us build sensors and clocks with a precision we've never even dreamed of. And fundamentally, it's forcing us to rethink the very fabric of the universe.
Which brings us to one last big question. If you can teleport the complete information of an object and rebuild it somewhere else, then what's the fundamental thing? The physical stuff or the information that defines it? The spooky connection that baffled Einstein might be telling us that the universe, at its deepest level, isn't made of matter and energy, but of pure information.
If you want to keep exploring the biggest ideas in science, make sure to like and subscribe.